Hey YouTube, this is Mike Shackelford, also known as the Wizard of Odds, and I'm joined by my friend Kathy, and we are here to do what's known as the 2 Dice Challenge. Let me give you a little bit of background. In 2013, somebody asked a question on my forum as follows. Mike, if you shake 2 dice and ask someone to peek at them, go ahead and peek at them. Okay, I could see them, so you just peek at them, but don't show me, okay? Okay, was there at least 1 2?
No.
Okay, shake them again. Was there at least 1 2 this time?
Yes.
Yes. Okay, what are the chances that there are 2 2s, given that there's at least 1 2? And I'm not going to tell you the answer until the end of the video. But this question has propagated an argument lasting 9 years on my website and over 1,600 posts. So suffice it to say, it was quite controversial, and we are here to resolve that with real money. There's somebody else in the room who has agreed to bet on the side. Excuse me, I'm going to pay 8-to-1 odds every time there are 2 2s. If there's 0 2s, nothing happens. If there's 1 2, then Kathy loses. So many people believe that the chances of 2 2s given at least 1 2 is 1 in 6 because the dice have 6 sides. I think it's less than that, and I can afford to pay those 8-to-1 odds. Now, Kathy is not betting her own money. She is a proxy for someone else in the room who didn't want to appear on the video. So Kathy, thank you so much for doing this.
You're welcome.
Okay, so here's the $200. I'm going to give you 200 in chips. The reds each represent $5, and the greens represent 25. So go ahead and bet $5. Is the scorekeeper ready?
Yes, sir.
Kathy, go ahead and shake the dice, and this time you can just lift up the lid. No, shake them and then lift it. There is 1 2, so you lose. Go ahead and do it again. Another 2, you should have bet 1 chip, so you lose. Go ahead. And you lost again, so you owe me $5. And we're gonna keep doing this for a while. Nothing happens because there's no 2s. Nothing happens. 0 2s. 0 2s. 0. And there's 1 2, so you owe me $5. 1 2. 0. 0. 0. 0. 0. 1. Thank you. 1. 1. 1. 0. 0. 0. 0. 1. 0. 1. 0. 1. 1. 1. 0. 0. 0. Excuse me, 1. 0. 0. 0. 0. 0, 1, 1, 0, 0, 0, 0, 0, 1, 0, 1, 1. You're not doing very well, Kathy. Would you like to break one of those greens? There you go. 0, 1, 0, 0, 0, 0, 1, 1, 0, 0, 0, 0, 1, 0, 0, 0, 1. Would you like to break another 25?
Sure.
0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1. I'm showing you here. I expected to win, but not this badly. 1, 1. Let's break another 25. 1, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0. Yay!
Hey!
Got one. So I owe you $40. Congratulations. But let's keep it going. 0. And by the way, the true bettor on your side has agreed to do this until he loses $200. So let's keep it going. 1, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0. Yay! Another winner for Kathy. $40 your way. Zero, 1, 1, 1, 0. Another winner. $40. 0, 1, 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 1, 0, 0, 1. Another winner. $40. 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 0, 0, 0, 0. So Kathy, you're down to your last $5. May the odds be with you.
Thanks, Mike.
Let's see what you got. 0, 0, 0, 0, 0.
Congratulations, Mike.
Thank you. Well, Kathy, thank you so much for helping with this. I really appreciate it. And I hope you enjoy the rest of your stay in Las Vegas.
Thanks, Mike.
Okay.
Bye.
Bye. Okay. I'm back, and I hope you enjoyed that challenge as much as I did. And at this point in the video, I'd like to go over what is the mathematical correct answer to the problem that was asked at the beginning of the video. And I will count to 5 to give you a chance to pause the video and work it out for yourself. 1, 2, 3, 4, 5. Okay, let's see if you got the answer correct. So there are two main camps regarding the answer to the problem at hand. One camp I will call the 1/6 camp, and the other camp is the 1 in 11 camp. Now, let's look at this diagram here. This shows all the ways you can roll 2 dice. We will call the outcome of what I'll call die number 1 along this column here, 1 through 6, and we will call the outcome of what I'll call die number 2 up here, again, 1 through 6. And in the body of the table, I indicated the number of 2s between both dice. So you can see there's at least a 1 in this column for a 2, and at least a 1 for the row in which die number 1 is a 2. Every square where there was no 2 has a 0. So let's count the number of possible outcomes of 2 dice that have at least 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here we have established that of the 36 ways you can roll 2 dice, 11 of them result in at least 1, 2. Therefore, we can say the probability of rolling at least 1, 2 with 2 dice is 11 in 36. Now let's count the number of combinations of the ways to roll 2 2s. Just 1 right here. So we can say the probability of rolling 2 2s, given that there's at least 1 2, is the probability of 2 2s divided by the probability of at least 1 2. That works out to 1 in 36 divided by 11 in 36. Now we can factor out the 36 in the denominator of both the numerator and the denominator, and this reduces to 1 in 11. Therefore, the probability of the question at hand asked at the beginning of the video is 1 in 11. And this is not an opinion. I would stake my life on this. What gives me the qualifications to address this matter, you may ask? I have a degree in math and economics from UC Santa Barbara. I was an accredited actuary for many years, and I founded and write for what I believe is the best and most trusted website about gambling, Wizard of Odds, as well as being the author of the book Gambling 102. So, how about the other side? What is the argument of the 1/6 camp, you may ask? Their argument is very simple. The dice have 6 sides, not 11. That's it. That's their argument. And if you really press them, they will, how shall I put this? They will interpret the problem as follows. Let's say you have 2 dice shakers with 1 die in each one of them. You shake them both, you lift up the lid of one of them, and it's a 2. What is the probability then that the other shaker has a 2? The answer to that question is indeed 1 in 6, but that is a different question than what was being asked in the 2 dice problem. The 1/6 camp always reduces it to a 1 die problem. And a lot of them see the error of their ways once they are presented with a little bit of logic. But some of them will absolutely never concede. They have the faith of a flat earther and will just stick to their argument. The dice have 6 sides, not 11. So I don't know how any better to explain both sides than that. However, as mentioned at the beginning of the video, on my forum, there are 9 years and over 1,600 posts about this, and I will leave links in the video description so that you may see the argument for yourself. And I'd like to close this video by doing a little math analysis of the results of the challenge. Finally, in this video, let's go over the results of the 2 dice experiment. I have here the results of all 337 rolls. As you know, I didn't put all of them on video to avoid making this too long and boring, but I hope you will take it on faith that these were the results. So let's go next to the natural probabilities of each possible outcome. There are 25 ways out of 36 to get 0 2s. There are 10 ways out of 36 to get 1 2, and 1 way in 36 to get 2 2s. So out of the 337 outcomes, how many of each event can we expect to see? Well, let's take the total number of trials in the experiment and multiply it by the natural probability. So this shows us that the expected number of 0 2s is about 234.0. We could expect 93.6 trials with 1 2 and 9.4 with 2 2s. So if you just eyeball it, you can see that the actual results are pretty close to the expected. Not exactly because of random variation, but fairly close. But let's not just go with fairly close. Let's do a statistical test called the chi-squared test to see how these actual results compare with expectations. So here is the executive summary of how to do that. You take the actual outcomes minus the expected outcomes, or just the difference between the two, it doesn't matter which you subtract from which, and square it, and then divide that by the expected number for that event. And let's copy and paste this down to the other 2 events. And taking the sum of these statistics here, we get what's called the chi-squared statistic, which you can see is close to 1.7 in this situation. Okay, what do I do with that, you might ask? So then in Excel, we do the formula chi-dist, and you put in the chi-squared statistic and then the number of degrees of freedom. The number of degrees of freedom is 1 less than the possible outcomes of the experiment. In this case, there are only 3 possible outcomes: 0 2, 1 2, or 2 2s. So doing that, we get this value here, 0.4276 roughly. What does that figure mean, you might ask? That is called the p-value. And this suggests that in a fair experiment, 42% of the time you would get results that are even more skewed than this. And the rest of the time, the 57.2% of the time, you would get results that are less skewed. So you want to see a number that's right in the middle between 0 and 1. It can't be anything outside of that range. So we're comfortably close to the middle here. That tells me that I can be very comfortable that this was a fair experiment and that the actual results are statistically, how shall I put this, are within statistical expectations of the expected outcomes. Now you don't need to do all that math, by the way. Excel makes it easy. You can also do this function here, chi-test, and then you put in the first range the actual outcomes, and in the second range you put the expected outcomes. And there you get the exact same number. And this test is really easy to do, and it comes in handy for lots of different situations where you're checking if the results of some kind of experiment are in line with what is mathematically expected. So that is all I have to say. Thank you for making it to the end of the video. I would like to give a big thanks to Kathy for being my proxy in the video, and for the gentleman who does not wish to be named, who provided the suite and who bet against me in this video. So that's it. Please give this video a thumbs up if you like it. I'm going to say for now that you can leave your comments below. However, if you guys write nasty stuff about Kathy, I'm going to disable the comments. And if you like this, please check out my other videos about gambling, or better yet, subscribe to my channel. Thanks again, YouTube. Bye.